10 songs can you buy so that it will add up to no more than $15? Is there more than one answer? How many premium can you get? How many top 10 can you get? So that's what we're focusing on today. So if we look at problem 1, we have y is less than 2x minus 3 and 2x plus y is greater than 2. What we're doing here is we want to graph our constraints or our inequalities. So our first step for the blue one is to look at the slope. Now remember, slope is the coefficient of x. So what's the coefficient of x? 2. So therefore our slope is 2. And our y-intercept is the number that's not being multiplied to x, which would be negative 3. And the coordinates of y-intercept are 0 and whatever number it is on the y. The red one's a little bit different. 2x plus y is greater than 2. Now think about it. What is different from the red constraint versus the blue constraint? We need to first have y by itself. So how do we get y by itself? We're going to subtract 2x on both sides. So then we're left with y is greater than 2 minus 2x. Now we can find our slope and our y-intercept. So again, our slope is the coefficient of x, so that's negative 2, and our y-intercept is 0, 2. So now when we graph it, we have to look carefully. Because the blue one is strictly less than and the red one is strictly greater than, those graphs will have dotted lines. So let's look here. Here are the dotted lines right here. So you can see the blue is this line right here, and the red one is this one right here. We graph it like we graph equations. First, because our y-intercept is 3 on the blue one, negative 3, this is 0, negative 3 here. This is our y-intercept. And then we're going to go, our slope is positive 2. So it's up 2 over 1, up 2 over 1. Or conversely, it's down 2 to the left 1, down 2 to the left 1. Now, to graph the red one, our y-intercept is positive 2, 0, positive 2, but our slope is negative 2. So what we do is we go down 2 to the right 1, down 2 to the right 1. Or conversely, we go up 2 to the left 1, up 2 to the left 1. Now, that's how you graph inequalities. But there also comes, you have more than one solution. So therefore, there's a certain side you shade, which is called the feasible region. The feasible region includes all the possible answers, solutions to that inequality. So it will make more sense. So to see what side we shade on, you're going to pick a random point that's not on the line. So say we're going to pick 0, 0. Because 0, 0 is not on either of these lines. So when we look back, I have 0, 0 right here, and that's our x and our y. So for every x and y we see, we're going to plug in 0. This is the first constraint. So is 0 less than 2 times 0 minus 3? Is 0 less than negative 3? No. And if we look at the red one, we plug in the same way. This is our x and this is our y. Is 0 greater than 2 minus 2 times 0? Is 0 greater than 2? No. So therefore, when you look at it, this 0, 0 right here is not a solution to either of these two constraints. So therefore, we're going to color our feasible region on the other side. So this is the side without 0, 0 right here. And then the blue one, this is our side without 0, 0. So now, when you have a system of inequalities, you have to look at what point intersects. Which intersects with that? When you look at it, the green is the intersection, and that's your answer. All of these values in the green right here, those are values that make both of these constraints true. That means that the left side, that the statement that you read after you're done, after you've picked in values, is going to be true. These are solutions to those both inequalities. So why don't you try the got it? So when you look at graphing systems of inequalities as you're doing your got it, remember, first you find your M and B, then you graph it, and then you pick a point to see where to shade when you find out which is the solution and which isn't. Now before you do that, sometimes you also have to find a y value. You have to set it equal to, you have to get y by itself sometimes to get it in that form. Now, problem 2, we're working backwards. So you're given a graph, you're given an inequality, and you have to find the inequality for it. So your steps are, first find the slope and the y-intercept, then test values to see which sign to use. So if you look here, I'm looking at A and B. So A is the blue one, the blue line. So to find our slope, we're going to see which points clearly hit the graph. So this point right here hits it, and this one. So I'm going to choose 0, -1, and 1, 0 to figure out the slope. So I'm going to do -1 minus 0 over 0 minus 1. So therefore, my slope is going to be -1 over -1, which is the same as saying 1. My y-intercept is when the line crosses, so crosses at 0, -1. And now I'm going to see which side what's my sign. So I chose a point that's not on the line, -1, 1. And I'm going to plug it in because that's what we normally do. So x and y, I plugged it in, and I'm trying to find out, after I do all the math, what is 1 to 2? It's less than. Now, I know it's not less than or equal to because, it's less than or equal to. And I know that because the line is solid. If it's solid, it's greater than or equal to or less than or equal to. So therefore, we can fill these all in. And this is what an inequality is. So the next one, we do the same process. We pick points over here. That's a clear point, and that's a clear point. 0, 5, and 2, 4. So I'm going to do 5 minus 4 over 0 minus 2. And that gives me -1 over 2. And my y-intercept is 0, 5. So therefore, I plug it into the y equals mx plus b. Y is what to -1/2 x plus 5. So again, I plug in a point that's not on the line, and I do all the math. Well, -1/2 times 0 is 0. So what is 0 to 5? Less than. But how do I know if it's less than or equal to? Well, let's look at the line. Since the line is dotted, it's strictly less than. So therefore, that is your systems. So our answer is y is greater than x minus 1, and y is greater or equal to x minus 1, and less than -1/2 x plus 5. So that's our answer. Greater than or equal to and less than. Let's double check. That was less than or equal to. So let's just fix that. All right. So now, the last problem, you have at most 6 hours to play basketball and do your homework. But you can't spend more than 2 hours on basketball, and you need to spend at least half an hour on homework. So this is where the solve it comes in. This is where all this is connecting. So when you put it all together, first you need to let x equal hours of basketball and y represent hours on homework. So therefore, this is at most time you can spend. This is hours on basketball you spend and hours of homework. Now, when we graph it, first let's graph this one, and then we're going to graph this one. So x is less than 2, it's right here. It's a straight line right here. Since it's less than, you're going to shade over here. Now, y is greater than or equal to 1/2. Here's 1/2. This should be dotted because it's strictly less than. Alright, so y is less than or equal to 1, greater than or equal to 1/2, it's up here. And the last one, x plus y, is less than or equal to 6. What's our first step? Solving for y. So, 6 minus x, our intercept is 6, and since it's less than or equal to 1, that's our slope, negative, so then we draw the line right there, and then we test values, and it's this side you shade. So what's the intersection of all these? Right here. It's a little bit, it's not as clear on your paper, so make sure you correct it. And here's your solution. So why don't you try to got it on problems 1, 2, and 3.